Welcome to the deep dive. Today we're zeroing in on something amazing, something you live in every day, your skin. And this deep dive is especially for you, our listener, stepping into your first year of medical school. Our mission. By the end, you'll grasp the skin's structure, its functions, so well. Ooh, you could break it down for a 10-year-old. That's the real test, right? We're working from a really great lecture on body tissues, plus some handy supplementary stuff. Should be pretty illuminating.
Absolutely. And it's so important because, we tend to just see the skin as, well, a covering. But it's so much more. It's this incredibly dynamic organ doing complex jobs constantly, mostly without us noticing. And understanding it right down to the cells and molecules, that's the key to understanding so many common diseases. It's actually quite fascinating how it all works.
Okay, let's jump right in the big picture first. If skin were a superhero, what are its main powers? What jobs does it actually do for us?
Superhero powers. I like that. Okay, first power, definitely protection. Think of it like a really strong, flexible, waterproof shield. It keeps the bad stuff out, germs, pollution, harmful UV rays from the sun. And just as vital, it keeps the good stuff in, mostly water. Keeps us from drying out, basically.
Oh, yeah. The barrier function. Makes sense.
Then there's immunity. It's not just a wall. It's got guards on the wall. Immune cells right there in the skin, watching for any invaders that might try to get through.
Active defense. Okay.
Power number 3, sensation. This is how we feel the world. Your skin is packed with tiny sensors. They tell your brain if something's hot, cold, sharp, smooth, gentle pressure, you name it.
Touch, temperature, pain, all that.
Exactly. Then, thermoregulation. Your skin is like your body's personal air conditioner and heater. Sweating cools you down when you're hot. Blood vessels near the surface open up to release heat. When you're cold, they clamp down to keep heat in. It's constantly fine-tuning your internal temperature.
Keeping things just right.
And it also has metabolic functions. It's like a little factory. For example, when sunlight hits your skin, it starts making vitamin D.
Oh, yeah. The vitamin D thing. Important.
Yeah, very. And it stores fat, which is energy storage and insulation. And finally, something maybe less obvious, psychosocial communication. Our skin is how we express things, how we connect. Blushing when embarrassed, goosebumps, the feeling of touch. Even things like tattoos or makeup. It tells a story about us.
That's a really broad range of jobs. So going back to our mission, explaining it to a 10-year-old, you could say skin is your body's supersuit. It's tough armor, has security guards, lets you feel everything, controls your temperature, makes vitamins, and even shows your feelings.
That's a great way to put it. Those anchors really help make it stick.
Okay, so how does it do all this? Let's peel back the layers, literally. You mentioned it's not just one sheet. Tell us about the structure.
Right. Microscopically, it's beautifully organized. We usually talk about 3 main layers. There's the epidermis on top. That's the tough, protective bit we see. Below that is the dermis, which gives it strength and flexibility. And then the deepest layer is the subcutis, mostly fat for insulation and cushioning.
Got it. Epidermis, dermis, subcutis. Let's start at the top, the epidermis.
Okay, the epidermis. This is our outer shield. It's mostly made of cells called keratinocytes. Their job is to make keratin that's a really tough protein. Think of the epidermis like a tiny building with several floors. The cells start at the bottom and move up, changing as they go. The bottom floor is the stratum basale, the basement, you could say. This is where new keratinocytes are born, constantly dividing. It sits right on the boundary with the dermis.
The cell factory.
Pretty much. Then they move up to the stratum spinosum, the spinous or prickle cell layer. Here, the cells start making lots of keratin, and they get linked together really tightly by things called desmosomes, like strong Velcro. Holding them together makes the layer tough.
Okay, strong connections.
Moving up again, we hit the stratum granulosum, the granular layer. This is kind of the last stop for living cells. They start losing their insides, their nucleus getting flatter and harder. They're full of these granules containing important stuff, like filigrin, which bundles up the keratin fibers really tight, and other things that help form the final waterproof barrier.
Filigrin.
Is that important?
Oh, very.
Yeah.
If you have mutations in the filigrin gene, you're much more likely to get things like eczema or severe dermatitis. Shows how vital even these tiny details are for healthy skin.
Wow, okay.
Now, in places like your palms and soles where skin gets a lot of wear and tear, there's an extra layer here called the stratum lucidum. It's a clear, thin layer just below the very top surface. Adds a bit more toughness.
Only in thick skin. Got it. And finally, the roof. The stratum corneum. This is what you actually touch. It's layers upon layers of dead, flat keratinocytes called corneocytes now. They've lost their nucleus. They're just packed with keratin. Think of them like overlapping tiles stuck together with a waxy lipid cement. This is the main barrier, keeps water in, keeps nasties out, and these cells are constantly shedding off the top as squames or flakes.
So that's why our palms are tougher than, say, our eyelids. The stratum corneum is thicker.
Exactly. It thickens up in response to friction and pressure. Very adaptable.
Amazing. But you said the epidermis isn't just keratinocytes.
Correct. There are other key players in the epidermis, nestled among the keratinocytes, mostly down in the basal layer. You've got melanocytes. These are the pigment factories. They make melanin, which gives skin its color, and crucially protects us from UV damage.
Like built-in sunscreen.
Yeah.
Freckles and liver spots relate to these.
Yes. Freckles are usually just temporary spots where melanin production ramps up with sun exposure. Liver spots, or solar lentigens, tend to happen with age and sun exposure. That's actually an increase in the number of melanocytes in that area.
Interesting difference. Who else is in the epidermis?
You also have Langerhans cells. Think of these as the immune system's frontline security guards. They hang out mostly in the stratum spinosum, looking for trouble, like invading bacteria or viruses. If they find something, they grab a piece of it and alert the rest of the immune system.
Antigen-presenting cells, right?
Precisely. And then there are Merkel cells. These are specialized touch sensors, especially for light touch and texture. They're in the basal layer, connected to nerve endings, lots of them in your fingertips, which makes sense.
Okay, so the epidermis is this complex, multitasking outer layer. What about the dermis underneath? You said it's the framework?
Exactly. The dermis is the layer that gives the skin its strength, its elasticity, its resilience. If the epidermis is the protective paint and tiles, the dermis is the strong wall underneath. It's mostly made of the stuff called the extracellular matrix. Imagine a gel filled with strong fibers. The main fibers are collagen, which provides toughness, stops the skin from tearing.
Like ropes.
Sort of, yeah. Very strong ropes woven together. And then there's elastin, which, as the name suggests, gives it elasticity. Lets your skin stretch and snap back into shape. The whole thing has this kind of basket weave structure, which helps it resist forces from different directions.
Then what lives in this matrix?
Good question. The main cells are fibroblasts. They're the builders. They make and maintain the collagen and elastin fibers. You'll also find some fat cells, immune cells like mast cells and macrophages. And crucially, the dermis is full of blood vessels. They nourish both the dermis and the epidermis above. It also contains nerve fibers for sensation and lymphatic vessels to drain fluid.
And things like hair follicles and sweat glands, where do they fit?
They actually start developing from the epidermis, like little downgrowths, but they end up residing down in the dermis. Hair follicles, sebaceous glands that make oil, sweat glands, they're all anchored in the dermis.
Right. And what holds the epidermis and dermis together? You mentioned it was important.
Ah, yes. The dermo-epidermal junction. It's not just a flat boundary. It's a complex zone with a specialized structure called the basement membrane. Think of it as incredibly strong, specialized glue locking the epidermis onto the dermis.
And if that glue fails?
That's when you get big problems. Certain genetic conditions or even some autoimmune diseases can attack proteins in this junction. The result is the layers separate easily, leading to fragile skin and painful blistering.
Okay. And then below the dermis? The subcutis.
The subcutis, or subcutaneous fat, it's mainly adipose tissue fat cells. Its job is insulation, keeping us warm, storing energy reserves, and acting as a shock absorber, cushioning deeper tissues from bumps and impacts. It also helps anchor the skin loosely to the muscles underneath.
Wow. Okay, that's a lot going on in there. It really paints a picture of how intricate the skin is. So knowing all this, how does it help us understand common skin problems? Things you might actually see.
It helps immensely, because now you can pinpoint where the problem is happening. Let's take sunburn.
Okay.
We talked about UV damage. Sunburn is basically an acute inflammatory response to too much UVB light, what's happening microscopically. Your keratinocytes in the epidermis are getting damaged, and many undergo apoptosis-programmed cell death.
They sacrifice themselves because they're too damaged.
Right, and the body sends blood flow to the area to deal with it, causing the redness, erythema, and swelling edema you see and feel. And we know chronic sun damage leads to things like wrinkles, age spots, and increases the risk of skin cancers, like basal cell carcinoma and squamous cell carcinoma, which arise from those epidermal cells.
Clear link there. What about something like vitiligo?
Vitiligo is fascinating and sad for those affected. It's an autoimmune condition. Remember the melanocytes, the pigment factories, and the basal layer? In vitiligo, the person's own immune system mistakenly attacks and destroys those melanocytes. So no more pigment is produced in those areas, leading to those distinct white patches of skin. It shows how the immune system, our guard, can sometimes go wrong.
Okay. How about acne? Super common.
Acne involves those structures down in the dermis, the sebaceous glands, which are attached to hair follicles. Usually around puberty, hormone changes can cause these glands to produce way more sebum, or oil. That excess oil, combined with dead skin cells blocking the opening of the follicle, creates a perfect environment for bacteria, specifically one called Cutibacterium acnes to thrive. This leads to inflammation, redness, pustules, all the things we associate with acne, usually on the face, chest, back where those glands are numerous.
So it's oil glands, bacteria, and blockage.
Pretty much the key factors. Then think about epidermolysis bullosa, or EB. We mentioned the dermo-epidermal junction, the glue.
Right, the fragile skin condition.
Exactly. EB is often genetic. Mutations affect the proteins that form that glue. Could be keratin proteins inside the basal cells, or collagen fibers that anchor the epidermis down. So even minor friction causes the layers to separate and blister. It's a direct, devastating consequence of a failure in that specific structural component.
That really highlights the importance of those connections.
Definitely. Or take something like a port wine stain nevus flammeus. That's not about cells malfunctioning, but about structure. It's a birthmark caused by malformed capillaries, tiny blood vessels, in the superficial dermis. They're dilated and don't constrict properly, leading to the persistent red or purple mark. It's a vascular issue within the dermal layer.
It really makes sense when you connect the condition to this specific layer or cell type involved. Okay, we've covered the biology, the structure, what goes wrong, but skin is more than just tissue, isn't it? It's so tied up with how we see ourselves, how we interact.
Absolutely. That psychosexual communication role is huge. Skin is fundamental to our self-image, our identity. Think about it. Humans have been decorating and modifying their skin for millennia. Cosmetics, tattoos, piercings. Now cosmetic surgery. These aren't just trivial things. Marking the skin, changing its appearance, has deep cultural roots and social significance. It's about identity, belonging, expression.
So skin diseases must have a massive impact beyond the physical symptoms.
Oh, enormous. The psychological burden of visible skin conditions can be completely disproportionate to their medical severity. Think about severe acne in a teenager or widespread psoriasis. It can lead to anxiety, depression, social isolation. It profoundly affects quality of life. As a future doctor, you have to remember that. You're not just treating a rash or a lesion. You're treating a whole person whose experience of the world might be heavily impacted by what's happening with their skin. Understanding that psychosocial dimension is critical for providing truly good care.
That's a really vital point. Okay, what a journey. We went from skin as a superhero shield down through the microscopic layers, the epidermis floors, the dermal framework, saw how specific cells do specific jobs, and how problems in those areas lead to disease. And finally, how it all connects to our sense of self.
It's been a good deep dive. Hopefully you, our listener, now have a much clearer picture. The skin is just incredibly complex and vital. So think back to that mission. How would you explain it to a 10-year-old now? Could you use that body's armor idea? Or the skin building with different floors for the epidermis? Maybe talk about the pigment factories or the touch sensors. Using those kinds of metaphors, those anchors, is not just good for explaining to others, it really helps lock the information in your own mind.
Definitely. Practice makes perfect. And maybe a final thought to leave you with. Consider all the constant, subtle things your skin does every day. Feeling the breeze, the warmth of the sun, the texture of clothes, a reassuring touch. And think about its incredible ability to renew itself, its role as an immune outpost. How might understanding that better lead to future breakthroughs? Maybe in fighting aging, maybe in healing wounds faster, or even preventing diseases before they start. The skin still holds a lot of secrets. Thank you for joining us on this deep dive into your body's amazing armor. We'll catch you next time on The Deep Dive.